Okay, everybody, let's see if I can recap the lesson. So today what we're doing is finding the angle from the unit circle. So anytime we see this symbol, inverse, sine inverse, cosine inverse, or tangent inverse, we know we're finding the angle. So if we take a look at, first of all, our unit circle, we have our angles either in degrees or in radians, and we have coordinates, either y, which is the sine, x, which is the cosine, or we did the tangents on the outside, okay, which of course is the y over the x. So let's take a look at the first example, sine inverse 1/2. So what I'm really asking is, find a y value of 1/2. Well, a y value of 1/2 occurs here and here. It occurs in two different places, but you have to take the one closest, always closest to 0. So the angle is 30 degrees or pi 6. Okay, on B, we want to find an x value, because it's cosine, of negative 1/2. It occurs here or here, but again we want the one closest, so the one closest is either 120 degrees or 2 pi thirds. As we see this thing arc, it's the same thing as the arc length, which is the angle in terms of radians, and to find an arc length of 1 of tangent, here it is. We know that's at pi fourths or 45. Now in this case we're just going to say pi fourths because we're looking for an arc length, so we don't want to have a degree. Cosine of 0, arc length of 0 is for cosine. 0 is the x value, so right here at 90 degrees or pi halves. So then sine inverse, now this is a little bit different because you've got a negative 1/2 y, and the negative 1/2 of the y is here. Now you got to be careful because you want the shortest distance, so we take the negative angle. So take negative pi 6 or negative 30 degrees, okay, because we take the shortest distance. We don't go all the way around, that'd be silly. Same thing with tangent of a negative square root of 3 or negative square root of 3 is right here. Again, we want a negative angle because it's the closest, which is a negative 6 degrees or negative pi thirds. The same question, cosine, we find an angle, so we're looking for an x value of negative square root of 2 over 2. Cosine, negative square root of 2 over 2 is here, which gives us an value, our angle of 135 degrees or 3 pi fourths. Tangent negative 1 is here or way over here, but again we want to take the one closest to 0, so we want the one that's negative 45 degrees or negative pi fourths. Sine of negative square root of 3 over 2 is going to be negative square root of 3 over 2 is here for sine. Again, we want the negative angle, it's closest, so it's negative 6 degrees or a negative pi thirds. Now, here's what we did. We talked about the domain. So if you're looking for a cosine, the angles you find for cosine are always found in quadrants 1 or 2. Okay? For sine, you want to find the angles in quadrants 1 or 4 because it's closest, but when you're in quadrant 4, you take the negative angle. And same thing with tangent. You want the tangent of an angle either in quadrant 1 or 4 because in quadrant 4 it's closest if you take the negative angle. Okay? Now, we talked about the cofunctions. Cosecant is the same thing as 1 over sine, so I changed to 1 over sine. And then I flipped the sign, so 2 is 2 over 1. I flipped it to make it a sine, and sine of 1/2 on the unit circle is at 30 degrees or pi 6, okay? Cotangent, same thing. You don't have cotangent on a unit circle. You don't have cotangent on a calculator. So you change it to tangent, because cotangent is 1 over tangent. I flipped them both, rationalized it, and then I found that that is at either 30 degrees or pi 6, okay, for tangent. Okay, right there. And then same thing with secant. Secant's not on your unit circle. It's not on the calculator, but it's the same thing as 1 over cosine. So I made that over 1. I flipped it, rationalized it, and I got the cosine of a negative square root of 2 over 2 is there at pi fourths or 135 degrees. Okay. Now, if I flip the page and I say, okay, what about if we do calculus? Now, calculators are easy, but I have to make sure I change my mode. So I went into my mode button, made sure my mode was in radians. So I went and changed my mode to radians, and then I was able to do these. I just used my calculator to do that. That's easy. That's easy. But this one's interesting. We got no solution because if you do sine inverse of a 1.2, you get an error. And the reason is because we're looking for a angle that has a sine value of 1.2. Well, the biggest value you can get is 1. 1.2 is off the unit circle. It's impossible, okay? Now, if you do the calculator for cosecant and secant, you don't have a button on your calculator, this cosecant or secant. You don't. So what you have to do is change it first into sine. Cosecant is 1 over sine. We flipped it. We did the sine inverse of 1 over 1.5, and we got our answer, okay? Same thing with secant. Secant's not on your circle or in your calculus. So I changed secant into cosine, 1 over cosine, 2 over 1. Then I flipped it, and actually is on the unit circle, and I found that at pi thirds. Finally, example 4. What if it's not even on the unit circle at all? Then you have to go ahead and do a little bit of math. Well, I said build a triangle first. Okay, so build a triangle, because tangent inverse is an angle. It's an angle from a triangle. So I know tangent is opposite over adjacent, so tangent of 2/3 is 2 over 3. I used Pythagoras' theorem to find the radius. And once I got the radius or the hypotenuse, then I could find the cosine of this thing, because that's what I'm asked for. Cosine, which is the adjacent over the hypotenuse. I got 3 over square root of 13, but I rationalized it, and that's the answer I got. Okay, that's all I have for today. Tomorrow we'll review, and then we'll take the test on the next day.